chapter 4 so far. But I want to give you some new names for them. Arc sine is the same thing as the inverse of sine function. So you saw this earlier in the year when I was talking about psi y cos x, tangent is y over x, and we learned that sine is y over h. Well, a sine inverse, all it would do is it would switch the sides and the angle from their normal location. Remember, normally we would say sine theta equals y over h. Well, arc sine, also known as inverse sine, just means you switch the angle and the side. So that's what we're working with. When you see arc sine, that means sine inverse. Just the same, arc cosine would mean cosine inverse, and arc tangent could be tangent inverse. They are one and the same. Some things that we'll get to work on is using our hand trick to find the exact value. So again, for those that you just watched it on YouTube, maybe you were absent, missed class, maybe I wasn't there to explain to you, here's what you do. You take your left hand and you're looking at your palm normally when we use the hand trick. Well, that's when we start with an angle, because you would use your fingers. You would say that your thumb is pi over 2, your index finger, your pointer finger is pi over 3, your middle finger is pi over 4, your ring finger is pi over 6, and your pinky would represent either 0 or 2 pi. Your pinky's the x-axis, your thumb is always the y-axis. Well, here we're given an inverse. And so an inverse, remember when what we do with our hand trick was we'd choose an angle, we'd bend our finger, then we'd turn our hand over, and then we would count fingers. And remember, the fingers always were square roots. Well, in this case, when we do the inverse, we're starting backwards. So if you take your left hand, you flip it over, so you're looking at the back of your hand. Now sine is the y, and y values are above x. Remember how we say psi y cos x, tangent is y over x? So y here, even though I know this is h on the hand trick is always 2. Y are the top fingers, so you'd count 2 fingers and you'd bend. So if you're with me, you should be bending your middle finger. And so then you'd flip your hand over and you'd open it up and say, okay, what value is that middle finger? Well, the answer is, it's my pi over 4 finger. Or if you were working in degrees, it would be 45 degrees. So that would be the value. So here's a picture of the unit circle, and they're showing you that this value, that would be the cosine, this is the sine, here is pi over 4, or 45 degrees, just as I showed you right there. And so there, I boxed up my answer. It's either pi over 4 or 45 degrees. They listed in radians, just because radians, again, if you've been with us, you know that radians are a lot easier to solve with. Degrees, it might be easier to give a direction to someone, but as far as mathematics are concerned, the radians are always easier to solve with. So that would be our 2 answers. Let's try another one. It says find the exact value of arc sine. Now, again, arc sine is the same thing as sine inverse. And so here's what we would do. If it's sine inverse, you don't start looking at the palm of your hand, you start looking at the back of your hand. This is telling me how many fingers. Now, I'm going to have 3 fingers. So I go count them, my pinky, then I have to see my, I'm counting from the top because it's a Y. So my pinky, my ring finger, then my middle finger. That's 3. So I'd bend my next one, which is my index finger. I flip my fan back over, and I open it up and say, what value is that? Well, my index finger is my pi over 3 finger, which in degrees, if you think 180 divided by 3 would be 60 degrees. So that would be the value. And I'm doing this without a calculator. You could type this into the calculator, obviously, but that would be the value. Now, before I actually box that up, I've gone too fast here. The value is negative. So I'm going to use the ASTC rule, which again meant that all things are positive here. Sine's positive here. Tangent is positive here. Cosine is positive there. Again, the proof on that is that if you think about in terms of x's and y's, and on both the A and C quadrant, x's are positive. Your x's are positive here because it's to the right. Your y in the first quadrant is positive because it's up high. Down here it's low, so the y's are negative. On this quadrant, x is negative and y is negative, and over here, x is negative because it's to the left, but it's up high, so y is positive. If you think about it, psi y, sine's positive, cos x, cosine's positive, tangent is y over x. So everything's positive because a positive divided by positive is still positive. Here, only sine is positive. Cosine would be negative. Tangent is a positive divided by a negative. So it's negative. So that's how we come up with this This says it needs to be negative, so I've actually given an improper value. To be negative, it needs to be down low. It needs to be in one of these two quadrants. Now the rule for inverses is it finds the quickest answer. So the quickest answer, what do I mean by that? You always start from here. The quickest answer is going to be the one in the fourth quadrant. You get there before you could ever get to the third quadrant. No matter if you went this way or this way, you get to the fourth quadrant first. So what is my pi over 3 in the fourth quadrant? If you remember the rules, again, I'm going to keep adding little things. The first quadrant, there's nothing in the numerator. Second quadrant, it's a -1 rule. This one's a +1 rule. And this is the times 2 -1 rule. What does that mean? You go to your denominator. I need it to be in the fourth quadrant. So I multiply the denominator times 2, and then I subtract 1. Well, 3 times 2 is 6 minus 1 gives us that 5. So the actual answer here is 5 pi over 3, or negative 60 degrees, because we're going down, negative 60. And if you needed to find a coterminal, you would just add 360 to that, or add 2 pi, subtract 2 pi, yada yada. So that's the quickest answer, is 5 pi over 3 or negative pi over 3. Let's see how they give the answer. They refer to it as negative pi over 3. So they just said if we're going down, let's just change it to negative pi over 3. So again, they put it that way. We could have just gone here and put a negative just because we know we're going down to make sine negative. All right. Now let's try this one. Find the value of sine inverse of negative 2 pi if it exists. Now, if you look at, here's the problem here. This is an angle. So sine inverse is telling me to flip my hand over. No matter what you do, when you flip your hand over, you're counting fingers, you should have a square root. So this one does not exist. And again, I'll tell you why. Because no matter what, the sine values are between -1 and +1. Every sine value, not the inverse, every sine value, all sine values have to be between -1 and 1. They could be equal to it. And the reason is because sine, if you remember, is y over h. And our hypotenuse is always bigger than the y, or exactly the same side as if it was just a straight line. That's why these values are always between, the y value will never be bigger than the hypotenuse. So it's always between here. Now what does that mean? In a normal sine, it's got to be, the answer will be between these two. This is the inverse. They've flipped the answer to the inside. And negative 2 pi is negative 2 times 3.14 or whatever, so it would be negative 6.28. That's why it does not exist. If you type it in the calculator, it will give you an error. This is undefined. Because again, the sine values have to be between -1 and 1. Now I have one for you here for you to try.